To talk about how we can convert the decimal to binary if you have floating point numbers. Okay, so let's start with binary. So when you converted from decimal to binary, what you did was, let's say we had something like 54, okay, 54 to the base 10. When you wanted to convert this to binary, what you did was you just started dividing it. Yeah, so you divided it and you wrote down the remainder. Okay, so it will be 0, then you divide it by 2 again, so it will be 13 and 1 remainder, and you will divide it by 2 and it will be 6 and 1 remainder. You can divide it by 2 and it will be 3 and 0 remainder, and it goes on, and finally you will get the answer. Okay, so 54 to the base 10 will be equals to, you will go from bottom to top obviously, so it will be equals to 110 to the base 2. It was pretty simple. When you have something like a floating point number, what you have to do is you have to multiply by the base. Okay, so let's say we are converting something like 0.125. Okay, we are converting 0.125 to the base 10 to the binary number. What you have to do is you have to multiply this number by 2. But this has a unique way of finding the answer. Okay, so let's write that down first of all. So we have 0.125. What you will do is you will multiply it by 2. Okay, since we are converting to the binary, we will multiply it by 2. Okay, so when you multiply it by 2, what will you get? Well, it will be equals to 0.250. Okay, what you have to do is you have to mark this down. Okay, so this 0, okay, this 0 actually represents the first decimal point of the binary number. So it will be 0.0. Then again you will have to multiply it by 2. So it will be equals to 0.500. Here also you have 0. Now this is the second decimal point. Now you will multiply it by 2 again. Now you get 1.000. Once you reach 000 after the decimal point or the floating point, the point, you can stop multiplying. And because you will get, again, if you multiply by 2, you will get 000. Here you have one right, that one will go here. And that will be the end of the answer. That's it. That's it. So 0.125 to the base 10 will be equals to 0.001 to the base 2. Okay. What if? What if you have to convert it to octal number? Well, that's also easy. What you have to do is 0.125. Here you have to multiply it by 8. That's it. So if you multiply it by 8, you will get 1000. I mean, 1.000, 1.000. You just have to write down this 1 here. So it will be equals to 0.1 to the base 8. That's it. But if you have to convert it to hexadecimal, what will you do? Well, you will do the same thing, but you have to multiply it by 16. Okay. So if you multiply it by 16, you will get 2.000. Okay. So the answer will be 0.2 to the base 16. So this 2 is what you have to write down here, first decimal point. So you will do continuously until you reach 0.000. Okay, the 0 in the decimal values. Okay, after the floating point, or okay, or until the decimal value they expect from you, the number of decimals. For example, they may say they need 4 decimal values. Okay, the 4 numbers after the decimal point. They might say like that. Okay, they might say like that. So that's what you have to do. So let's do some questions. Okay, let's do some questions. Let's say we have 0.625 to the base 10. Okay, you have to convert it to binary. Okay, what do you have to do? You have to multiply it by 2. So you will multiply it by 2. So that will be equals to 1.250. Okay, so since you have 1 here, you have to write that down first. So it will be 0.1. Okay, now when you multiply it by 2, you may get 2500. But what we are focusing here is only the part that is after the floating point. Okay, only the part that is after the floating point. This one we don't care. The whole number we don't care. Okay, so if you multiply it by 2 again, you will get 0.500 because this one has no value after that. You have to just multiply 250. So you'll get 0.500. So now this 0 goes here. Okay, you have to multiply it by 2 again. Yeah, because we don't have all zeros. So now when you multiply it by 2, you get 1.000. So you have to write down 1 here, and that will be the end of the question why we have reached the zeros in after the floating point. You have to do the same thing for octal also. So 0.625 you will multiply it by 8. So if you multiply it by 8, well, bingo, 48, 496, and it will be 5.000. So the final answer will be 0.5 to the base 8. 0.5 to the base 8. Okay. What about 0.625 into 16? We are converting to hexadecimal. Well, that will be equals to 10.000. It will be 10.000. Okay. It will be 10.000. So what will be the answer? Can you write down 10 to the base, 0.10 to the base 16? No, you can't. Because in hexadecimal, 10 is represented by A. So what you have to do is, you have to write down A here. A to the base 16. 0.A to the base 16. I know this looks cursed, but that's what happens when you are converting from decimal to hexadecimal. You just have to accept it and do it. That's it. Okay. Now let's try another question, but this time we are going to do something different. Okay. So let's say we have 5.375 to the base 10 and you are converting to binary, octal and hexadecimal. Well, when you have something like this, first of all, you have to divide this number into two parts. The integer part, 5 to the base 10 plus 0.375, the floating point part or the decimal part, 0.375 to the base 10. So now what you have to do is, first of all, you'll find 5 to the base 10. What's the value of 5 to the base 10? And then 0.375 to the base 10 and then add them together to find the binary, octal or hexadecimal equivalent. So let's do for binary first. So if you divide 5 by 2, you will get 2 and remainder 1. If you divide it by 2, you'll get 1 and 0. So 5 to the base 10 is equals to 101 to the base 2 because it's bottom to top approach. And 5 to the base 10 is equals to 5 to the base 8 and it will be 5 to the base 16. There is no changes. Okay. Because you can try it. Okay. If you want to divide, but we know 5 exists in 8 as well as in hexadecimal. So by 8, I mean the octal number system. So that's it. Now we are going to do 0.375. First of all, let's multiply it by 2. So if you multiply it by 2, you'll get 0.750. So since this is 0, okay, you have to write down 0.375 to the base 10 is equal to 0.0 first. Why? This is 0. Into 2 will give you 1.500. So which means you have to write down 1 here. Okay. Now when you multiply it by 2, okay, we will ignore this. So 500 into 2, it will be 1.000. So we have reached the end and there is a 1 here. So we'll write down that 1 here. Okay. Final answer. What will be the final answer? 5.375 to the base 10 will be equals to 101.011 to the base 2. That's it. You're just adding these two. Because if you add these two, you will get 5.375 to the base 10. Okay. And that's what happens here also. If you add these two, you'll get 101.011 to the base 2. Okay. Now let's convert to the octal into 8. So that will be equals to 2.4, 2.96, 3 at 24, 29.6, 3.000. Okay, the answer is direct. So you will write down this is equals to 0.3 to the base 8. So if I add these two, I will get 5.3 to the base 8 and that will be equals to 5.375 to the base 10. Okay, now we are going to find for hexadecimal. 375 into 16. So that will be equals to 6.000. How do I know it's 6.000? Because 8 ala perikana 3 varudana, 16 ala perikana 6 thane varum. Okay. If you multiply it by 8, you get 3. Well, if you multiply it by 16, you have to get 6 by 8. 16 is twice 2 8s. Yeah. So it will be equals to 0.6 to the base 16. So you can write this down. Okay. It will be equals to, if you add these two, you will get 5.6 to the base 16. Okay. So looks cool. Okay. Obviously it looks cool. But you can do even targeted ones. If they ask you to change to binary, if they ask you to change to octal, if they ask you to change to hexadecimal, that's your wish. Okay. So I'll just do one more question. Okay. Maybe a hard one. Yeah. Like, what about 25.8125? What do you think about that to the base 10? Well, first of all, we have to find for 25. So 25 to the base 10 will be equals to, well, I know it will be equals to 16. So 1, and then we have 9, so 8, no 4, no 2, 1. So it's 25 to the base 2. Yeah, I'm writing directly. I have taught you already. You can check it in the, the video. I'll put the link in the description. And then we have to find the 0.8125 equivalent for 0.8125 to the base 2, base 10. How can we find that? Well, we are going to multiply it by 2. So into 2 will give me 1.6250. So here we have 1, so it will be 0.1. And then if I multiply it by 2 again, it will be 1.250. So I have 1 here, so I'll put the 1 here. If I multiply it by 2 again, I will get 0.500. And then here we have 0, so I'll put the 0 here. And if I multiply it by 2, I'll get 1.000. So this will be 1 because we have 1 here. So it will be. So final answer will be 11001.1101 to the base 2. Okay. You can try it for octal and hexadecimal. Let me know the answer in the comments. I'll see you in a brand new video.
Thanks for watching the 6th video in our number system series. If you found this tutorial on converting decimal floating point numbers to binary, octal and hexadecimal helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master number systems and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.